All right, so let's do this question. This question looks like incline the plane. So let me start by writing down the steps of standard strategy, just as a kind of reminder and reinforcement through repetition. So the standard strategy says it's a 4-step strategy that we teach. That I really highly recommend that you try following. It's a little bit different from your textbook and other resources. And that's because we have spent a lot of time streamlining Newton's law strategy problem solving techniques, and this is, I think, the kind of universal way you can approach force questions in a really shortest number of steps. So step number 1, you draw free body diagram, and I'll be doing that soon. Step number 2, you define coordinate axis, and this is when you kind of think about in what direction the acceleration might be, and you choose your coordinate axis so that your x direction is along the direction of acceleration. That really simplifies a lot of things later. Step number 3, you break forces into components, or decompose forces into components. And finally, all these steps 1 through 3, it's really preparatory step that allows you to do step number 4 in as a streamlined way as possible, which is writing down Newton's law equation. Those of you who are experienced in physics problem solving, you might be able to skip to step number 4, but like I can skip to step number 4. But as you are starting out, I think it's really nice to have these bite-sized chunks that you can handle one step at a time, so that when you do the thing that you really want it to do, this is really what we are trying to do. You don't have to do the whole thing in one big jump. You can do it one step at a time. So I can start by drawing free body diagram. And sometimes the questions have figures in it, especially when they don't have figures. I like to doodle a little bit to make sure I correctly understand that there's an incline, and there's an applied force. Applied, and I think it's by up the incline they mean, so if I have an incline and there's a crate here, I think they mean to say the applied force is parallel to the incline. The ramp is tilted and they tell us that it's frictionless. Good. I was going to assume that anyway, but great if they, but later on they're going to tell us there's friction. All right. That's fine, but this is good because that means I am not going to ignore the y component of force. Or, although I could, they are giving us friction force directly rather than friction coefficient. Yeah, so I think I'm still gonna ignore I'll write down the equations for the y component of forces, and then I won't do anything with it because I don't need to. Okay, so let me draw free body diagram of the crate, and I really like to start out with the gravity. That makes sure as much as possible that I don't forget any forces that's there. Because the applied force, of course, you shouldn't forget. They tell us it's there, so you should draw it. And having drawn the applied force and the gravity, and this is the direction of the incline, looking at these two forces should tell you I'm missing some force, because these forces tell you acceleration is this way, and net force, and hence acceleration is that way, and that makes no sense. And after some thinking, I hope you realize there's a normal force coming from this surface of contact. So that's my and after having drawn normal force, then especially with the information that it's frictionless, it feels to me like it should be all the forces. So step number 2, define coordinate axis. I think I'm going to define it the usual way for most inclined plane questions, which is my x-axis is along the incline and y-axis is perpendicular to the incline. That does two things usually. One, it minimizes the number of forces that need to be broken into components, because both the applied force and normal force are along these axis directions. And even if that weren't case, like if there was no applied force, so either this or the straight axis would have given you the kind of same number of forces that you had to break into components. Here the acceleration, I think, is hinted as being kind of going along the incline, either up or down, possibly up. So I want my x-axis to be along the acceleration. So that's my step number 2. So steps 1 and 2 done. Step number 3, break forces into components. The only force I need to break is the gravity, and it's a first step of breaking force into components. This is going to become hypotenuse of a right triangle, and that right triangle should have legs going along the axis. So this is the x component, this is the y component, and once I've drawn this right triangle, then I figure out where in this right triangle should this angle be. And after you go through some geometry exercise, hopefully which you've done like dozens of times by now, and you can figure out by sight that it should be this angle theta. That gives me this side, that should be mg sine theta from SOHCAHTOA, opposite side, and this should be mg cosine theta from ka portion of SOHCAHTOA. This is the adjacent to the angle. So that's step number 3. And finishing steps 1 through 3 results in this annotated free body diagram, which is really the resource you are now going to use to step number 4 really quickly, as a matter of simply reading off the information that's annotated in this free body diagram. So let's write down step number 4. So net force in the x direction. I have two forces, apply the force and the x component of gravity, and I'm so for the purpose of these equations, I'm assuming acceleration is upward, and if I turn out to be wrong, there will be a minus sign that we can deal with it later. So apply the force upward minus mg sine theta is equal to mass times acceleration. Net force in the y direction is the normal force minus mg cosine theta is equal to 0 by choice. We defined our axis so that this would be true. So for what the question is asking, it's asking for the acceleration. I think I can just solve this one equation for acceleration. If it were asking me about normal force, I would use second equation, but it's not. So let's say acceleration is equal to divided by m, so F applied minus mg sine theta divided by m. So let me plug in these numbers and let's see. Do I want? Yeah. Let me plug in units this time. 7.2 Newton minus mass 3 kilogram times g. Now here I can just use gravitational acceleration. Wolfram alpha will look it up, and because I'm putting in units with every quantity, I can just have Wolfram alpha look up the constant. That's one of the reasons to put in the units if you're going to use that functionality of Wolfram alpha. Times the sine of 20 degrees. That's the net force divided by the mass, 3 kilogram. With the units, your decision basically has to be, put in the units for every quantity that needs it, or do it for none of them. Just keep everything basic SI units. Either is fine. I do think this is more complete and more comprehensible. I don't know why Wolfram alpha is not. Is in meter per second squared. I was saying negative number, so that must mean the crate is actually sliding down, not up. So here's the question. Does the question expect a positive answer or negative answer? Signed quantity or unsigned quantity. One could argue that this is only negative because I chose my x-axis wrong. If I chose my x-axis as going down the hill, then I would have gotten a positive answer. So when it's ambiguous, which is meant by the question, this two significant figures making me worry a little bit. Let me see. And if it says it's wrong, then try the other way. Maybe it's expecting a signed quantity. Maybe the question author agrees with you that this is the correct choice of axis, and your acceleration being negative, that's signifying that it's opposite to the applied force. Maybe. Okay, so I gotta do. Let's see. Is there? I wonder if there's a way to get it to. Because it's rounding to two significant figures, and I'm pretty sure that's the problem. Let me do it this way. I don't know how to make maybe in with at least 3 significant figures, maybe. I don't know. Will it understand that? It has natural language processing, but it's not like a ChatGPT. Yeah. Let me. So if you don't put in the units, then it'll actually use more significant figures. So let me do it that way. No. Yeah. So 0.9195. Oh. So this should have been graded as correct. The fact that it wasn't makes me think the question author might be using the like 0.1% tolerance. So let me make this 1.8. Yeah. And just to double check, positive version of that answer isn't being graded as correct. Yeah. So I think I will probably have to notify the author about that. You know, forcing the 0.1% tolerance. It's really, I think, annoying. Because especially if most other questions were using 1% tolerance. So, and I think I'm remembering one of your classmates reported an issue with this question, and that got me looking into part B. And I think part B actually does it wrong. But let me do it correctly. So, so this is the question. To which I think the question handles it incorrectly. The question is, so the textbook question itself, it's adding a friction force of 1.9 Newton. Now, in what direction is that friction force? Is that friction force going this way, 1.9 Newton? Or is it going this way, 1.9 Newton? Is it going with applied force? Is it going against applied force? And that's actually the wrong question. Really, there's a missing piece of information here, which is what's the direction of velocity of the crate. If the crate has been pushed up more strongly before, then the crate might have some upward velocity. In that case, you could make the argument that the friction force should be going down the hill to oppose the upward velocity. Maybe, and I guess that would be an answer that would be consistent with this acceleration here. Treat the resulting acceleration as being negative. Maybe there's some other unspecified reason. They up the slope would be positive x. Maybe it's moving in that direction already. If that's the case, in order to get the new acceleration, what I would be doing is I would be adding friction in the same direction as the gravity, which is going down the slope. So if I'm doing it that way, I would say minus friction force here. So for the acceleration, I would be doing minus friction force here. So the modification I'm making here would be, okay, I did a minus gravity, or the x component of gravity, and I do minus 1.9 Newton for friction. And I get minus 1.585 for significant figures for 0.1% tolerance. Again, I will look into getting that fixed. And I think it'll grade that as correct. And I think grading that as correct is, I think the question is ambiguous. Because someone else could think in a different way. Instead of somehow giving a special meaning to this, maybe you think it's more natural for a crate to start from rest. In that case, acceleration being down the hill means actually your friction force wouldn't be acceleration being down the hill and starting from rest, so it's gonna start to slide down. That means your friction force should actually be opposing that motion. So if that were the case, then you wouldn't be doing this. You would be adding plus friction force in the same direction as applied force. Plus friction force in the same direction as applied force. And if you did it that way, which again I think might be a more natural thing to do for most of the people who haven't looked at this question coding before, then you would get this answer, minus 0.318. One more significant figure, 5, minus 0.3185. And I think either more information should be given in the question to disambiguate this ambiguity, or answer key can be written in a way to accept both answers as correct, and neither has been done. And I'm pretty sure if I put that in as my answer, it will probably grade as or no, it might grade it as correct. No, yeah, that's because of the 0.1% tolerance, I think. Crazy. But anyways, those minor issues, I'll report that to the author to hope to have that fixed by next semester. So I've laid out all the reasoning. If you feel like you understood that, then great, you understood everything there is to understand about this particular question.